Okay, let us see another example here. We are still on uniform roads. A uniform road, big key of mass 18 kilograms and 6 meters long, resting in equilibrium at an angle theta to the vertical and to the horizontal, with its upper end P resting on a rough vertical wall and the lower end Q resting on a rough surface. Whenever I hear the word surface, rough, it means we expect some friction. Okay, if the coefficients of friction between the vertical wall and horizontal surface and the road are 3/5 and 2/3 respectively, find the reaction at P and Q, coefficient of friction at the vertical wall and horizontal surface, and then the angle theta. So start with a sketch. So we draw our, this is going to be our vertical wall, this is going to be our horizontal surface. Of course, we have our rod, or in some questions we find it as a ladder. So this is what we have there. Okay, so I have a rudder, P, then this is going to be my Q. So P resting on a rough wall. So you see that it is contact. Normally when it is contact, it means that there are going to be reaction. So I'm going to be having a reaction in here. So reaction at Q, at P. Then here I'm going to be having a reaction at Q. As simple as that. So this one is resting with an angle theta. We don't know that angle. This one is 6 meters long, and then has, because it's uniform, it means that now the weight is acting in the middle because the load is uniform. The moment we are uniform, it means that it starts acting in the middle. So from there, that is our main point. So weight is going to be there. How do you get weight? We get the mass times D. 18 times D, that's going to be our weight. So, meaning if this is the middle, so this is going to be 3. You get this divided by 2. Then this is going to be 3 meters. I'm starting with the basic. We are going to now and then going to give us the length. Anyway, so horizontal, vertical, that's going to be horizontal. Now, because this is a rough surface, it means that we are going to expect friction here. So our friction here is going to be FQ, which is given by the coefficient of friction. We have the coefficient of friction at the horizontal surface. Horizontal surface, the vertical and horizontal surface are 3/5 and 2/3. So horizontal goes with 2/3. So this is going to be 2/3. Then our Q, the reaction at this surface, remember our friction is given by mu R, the coefficient of friction, and then the reaction. So the reaction here is Q. So here, this is our vertical wall, because when they try to slide, you see when you try to slide, this rod is going to move to the side, so friction is going to act opposite. And when it's sliding, this one is going to fall down, so meaning friction is going to act up. That's why here I have my friction at P, which is going to be the coefficient of friction here, they are giving us 3/5. 3/5. The reaction here is RP with ease. So we are done with that. Basically. Okay, now we start resolve upwards, horizontally, and then we shall see if it's required for us to take moments. So let us resolve first of all vertically. If I resolve vertically, those forces, because this is in equilibrium, it means that this force are going to be equal to this. So this force here is 3/5 RE, then plus this one, which is RQ. They are going to be equal to the weight, which is 18B. That is the first thing we do. Then after that, we come and resolve. Okay, we call this equation 1. Now resolve horizontally. Horizontally, which forces we have? First of all, this one is going in that direction, so our RP, that's the only force going horizontal. So it is equal to 2/3 RQ. I call this equation 2. So now it's that we have RP, we put it there. So we say put 2 in 1. So now I'm going to say now 2/5. Now, my RP is 2 over 3 RQ, then plus RQ. I'm putting this in here, RP is here, then RQ is equaling to 18 gig with ease. So from there, sorry, this was what? This is 3 over 5. 3 over 5. 3 over 5. This one here. This one is cancelling. So I'm going to be adding 2 RQ over 5 plus RQ equaling to 18 times our is 9.8. So the whole of this one is simplified. This is going to be 5 plus this. We have 7 RQ over 5 equaling to 18 times 9.8. So start here, we can every get our RQ. So you see, I'm going to multiply this side and divide by this. So my RQ is going to be 18 times 9.8 times 5 over 7. So that I come and get our RQ. From there, our RQ is going to be so here I'm getting 126 newtons. So this is my RQ. So if I have RQ, remember I need also the friction there. So means that now for my FQ equaling to 2 over 3 RQ, means this would be 2 over 3 times 126. So my FQ is going to be 84 newtons with ease. So I have FQ, the friction at the horizontal surface. So after doing that, you know now I have RP there. I need the reaction at P. That my RP from what? From equation 2, so that my RP is equaling to 2 over 3 RQ, which will be 2 over 3 times RQ, which is 126. That my RP is going to be equaling to 84 newtons. Now, if I have RP, I can get my frictional force at P there. Remember that now our frictional force at P is going to be 3 over 5 times RP, which will be 3 over 5 times 84. So my FP here is going to be now it's going to be 50.4 newtons. So I have my frictional force at P. So that's what we had first. Now remember, I have now reduction at P, I have reduction at Q, I have the frictional force at the vertical wall, which is FP, I have the frictional force at the horizontal, which is FQ. Now we want to get the angle theta. So how are we going to get this angle? Now that one is going to call for taking reactions, moments. So you see, we have two forces here and there you have two forces. But the force is here, so it's easier for us to get the reaction, the moment here, because we can every get a distance, the perpendicular distance from here, this weight here. So it does take reactions at Q and clockwise. So how are we going to do that? First of all, anti-clockwise, how many forces do you have that are going anti-clockwise? Anti-clockwise, first of all, any force that is coming from Q is going to have its moment as 0. And there we use the idea of the principle of moment, which says the sum of anti-clockwise moments is equaling to the sum of anti-clockwise moments. So anti-clockwise, first of all, we have this one is going to act anti-clockwise, even this one. But because this is from where we are taking moments from, its moment is 0. Because the perpendicular distance from this to this force is 0. So now I'm going to just consider this one. So I'm going to now consider 18 G times what's the perpendicular distance. Now the perpendicular distance from here up to here. there, I'm going to first construct a simple triangle here, right angle. Now this one is going to be my theta. Remember, from here to here, I'm considering this triangle here. It's going to be 3 meters. Okay, so I need this one. So this one is, because this is adjacent, it goes with cos. So this one is going to be 3 cos theta meters. Okay, so I need now this perpendicular distance. You see, this is the force. So I need the perpendicular distance from here, where I'm taking moment, to this force. That's why I'm getting this. So times 3 cos theta. So that's the only upward, that's the only anti-clockwise moment here, because this is going to be 0 and this is going to be 0. Okay. And clockwise, clockwise, we have this first of all. You see it's going to go clockwise now. So I have RP times, what is the perpendicular distance from here? So the perpendicular distance is going to be from here up to here. But you see, if this is the theta, okay, let me also put that so that people can able to see what we're talking about. So if this is theta, and now here, the R is coming up here, so the length, the hypotenuse is going to be 6. So this is 6 meters, meaning we want this. But this one is going to be what? This is now 6. This is opposite to this angle, so 6 sin theta. Here this one is going to be 6 cos theta. Depends on the hypotenuse. Here it was 3, but this is 6. Because this one, we are from here up to here. But now this one, we are from here up to here. That's why I'm using that. So my RP, the perpendicular distance now, from here up to here. Remember, our RP is here. So you want the distance from here up to here. Because this P is the same as from here up to here. It's going to be the same from here up to here. So it's that now the perpendicular distance from here up to this force is going to be this, which we have seen is going to be 6 sin theta. Then plus, we have also this force here. You see it's going to act clockwise. So its distance from here up to is the perpendicular distance, because the force is there. So what distance from here up to here, which is going to be this. So I have FP, then times 6 cos theta. So after that, we substitute what we have, and then we simplify. So I have this as, let us put, this is going to be 18 times 9.8 times 3 cos theta equaling to RP is 84 times 6 sin theta plus FP is 50.4 times 6 cos theta. Let us simplify and see 18 times, so it's giving me 5 to 9.2 cos theta equaling to, this is 504 sin theta, then plus 302.4 cos theta. So it's now, I can bring cos's this side. So you see, when I bring this side, I'm going to be having now 5 to 9.2 minus 302.4 into now cos theta equaling 504 sin theta. So from there I can every form a tan. So this one is going to give me this one is going to give me 226.8 cos theta equaling 504 sin theta. So you can every form tan. Okay, this one you can skip, but this I want I'm doing this so that people can follow. Over 504 equaling 2 sin theta now over cos theta. So from here is that this is going to give us tan. So our tan theta is going to be 226 0.8 all over 504. But from here, you can only get to this step and you get as our theta. So our theta is going to be, we get that divided by this is going to be now 24.23 degrees, and that's going to be 2 decimal places. So that's our angle theta. Basically, that's what we have to do. These are very simple things. Ladders are the easiest. I think you can see. Basically, that's our angle theta. That's it. I wish you well.